you're just going to get a whack of questions. Do you use kinematics? Do you use dynamics? Do you use energy? That's the million-dollar question. Okay, you got to know how to solve it. That's what's tricky about it. Right now, you know it's energy chapter, so hey, seems kind of simple, right? That, ooh, I don't know, a force there, ooh, kind of looks like dynamics. I'm talking about a speed here, that's kinematics. Oh, you just got to remember, sometimes you want to do energy. You might try it one way and go, I'm stuck. I don't know what to do. Let's try it a different way. Okay, let's try it with energy. Maybe it'll work both ways. Then you can do that and do it twice. Like Natasha would. Okay, and just to check your answer. That's how some kids get 99% in the course. Did I tell you? Actually, not her. I didn't have her, but her sister got 2 questions wrong all semester. The whole semester. 2 questions wrong. That's it. Okay, so I'm going to use conservation of energy. What do I know here? Energy is conserved. Okay? And there's lots of different kinds. There's like 1/2 mv squared, and is there any potential here? Or is this thing going completely horizontally? It is. And we know the bullet does drop a little bit. We don't know how far this block is, but it does get sucked down to Earth at 9.8 meters a second. But, okay, it doesn't say shooting it up, doesn't say shooting down or anything. So MGH doesn't really have any effect in here. I know work is change in energy. Okay, that's the work energy theorem, and we've done questions where that is 1/2 mv squared final minus 1/2 mv squared initial. But also we know work is what? Oh, force times the distance. Hey, do we have a force here? Yeah, do we have a distance here? Okay, well maybe we can do this with energy. All right, so work is the change in the energy. Work is force times distance. What's my change in the energy? I got 1/2 mv squared. And that v is the kinetic energy of that bullet. Okay? Whatever energy that bullet has is going to be conserved and converted into work in the form of a force times a distance. Right? Because I got the force on this block of wood, and I got a distance that that bullet travels in the wood. That's a force times a distance. Now, it is kind of confusing, because there was a question yesterday. It's like, well, what heck force are we using here? Is it like, if I got a rocket, is the force of gravity? Force of thrust? Is it a net force between the two? And I know it's a little bit confusing. This question only has one force in it, okay? There's no gravity, there's no thrust, just one force. So that's your kind of clue that, you know what, I could probably use this. Okay, if there's a bunch of forces going on, it's a little more confusing, I will admit. Okay, well, 11,200 newtons times 1.23 meters is 1/2 times, what's the mass of what am I talking about here? The block of wood? Yeah, I should actually put in the mass of the block of wood in here just to confuse you. 49 grams, that's the only mass I got here, so that must be the one I'm going to use. Do I want that in grams? No. 0.049 times v squared. So v is the square root of that times 2 divided by 0.049, and hopefully, if you do that properly, you get something that looks pretty darn fast. What's that in kilometers an hour approximately? 2,700 kilometers per hour? Does that seem reasonable? That's what it is. That's a 577 T-Rex after all. Okay, you remember that video I showed you where the guys are holding the gun and it's like blowing them backwards into the wall? That was it. That was the gun. Okay, so I don't know if it's the most powerful rifle on the planet, but anyway, it's what it is. Okay, I got one more for you. It's not really, I'm just going to try to, this is number 34. I just want to get you started. And I wasn't going to give it to you, but I thought there's only about 3 questions left to do. So I thought, what the heck. And yeah, I want you to do this both ways, because if you do it the force dynamics way, it can be review for your midterm, which is probably in about 2 weeks, week and a half. Okay? So number 34, you remember our good old blocks on inclines? It's moving up here at 11 meters a second. Is there a force applied on it? No. If you read the wording of the question, that's after something pushed it up at that speed, okay? So there's no applied force going up here. Okay, it moves up here some distance. And we did questions where we did the distance, but this question actually says, what's the height? This thing is 5 kilograms, and there's a force of friction on the block of 9.4 newtons. This angle is 30 degrees. So we did this with forces, dynamics, okay, and some kinematics in this case. So I want you to do that for review purposes, but energy, solving this thing for energy, this thing does have kinetic energy. It's going to all get transferred into what form? Yeah, when this thing stops. And when it stops, well, you know the velocity up here is going to be 0. Okay? But there's also something else we need to look at. And you've done some questions already like this, right? Some energy is spent. This is a more real-life practical question because in life, things aren't frictionless. You're always going to lose heat. There's never anything that's 100% efficient. So what do I do with that thing? That is a force, and this force applies for how long this distance is. Okay, when it stops, well, there's no more force of friction. Okay? Now that's not the applied force here. That's just one of the forces. What's the other force on this block as it goes up? Yeah. So I'm not doing this. I want you to do this because you've done this before. But remember, it's a component of the weight. So force of friction is that way. That always opposes the motion. We also have this. So this plus this, that's your net force as reviewed. Okay? You're going to solve it that way. Energy says 1/2 times 5 times 11 squared is 5 times 9.8 times some height, okay, which is, that's what the question is. And we're giving you an opposing force applied over this distance. Can I solve that for h? Yeah, I got 2 variables. What the heck's d? Is there another way to get d? Because I didn't draw this correctly. That block's here, and it goes to there. Right? Well, a little grade 10 math. That's h and that's d. Do you see a relationship between h and d we can use to substitute in there? Yeah. Sine 30 is h. I know it's the easy stuff, right? Okay, so d is h over sine 30. You can put that in here. You got one equation, one variable. Solve that thing for h using energy. Then do it with dynamics just for midterm practice. So 41 to 45, but not 43. And then do this guy. And that's it. We'll have a little quest on this in 2 days. So if you're all done and you think you're ready tomorrow, I'll actually hand out some P&E stuff. We can get a little head start on that. Okay, and that's what we'll be doing Friday and Monday as well.